All right, we're just going to do a couple of examples of graphing secant and cosecant by hand using transformations. All right, so here we're graphing a secant curve. So the first thing we want to do is just think about, how do I sketch a basic secant curve? Okay. So I'm going to put a couple of things down on here. Let's see, there's 0. Let's do pi over 2 and pi and 3 pi over 2, negative pi over 2, negative pi, negative 3 pi over 2. Okay. Now, secant, remember, is the reciprocal of cosine, or it's 1 over cosine. So a handy place for us to start, put in 1 and negative 1, 2, is to think about what happens at 0. At 0, cosine is equal to 1, which means that secant is also equal to 1. The other thing that's handy to think about is, where is cosine 0? Because anywhere cosine is 0, secant is going to be undefined. Well, cosine is 0 at pi over 2, meaning cosecant is going to be undefined at pi over 2. At pi, cosine is negative 1, which means secant is also going to be negative 1, because 1 over negative 1 is negative 1. And then cosine is again undefined at 3 pi over 2. On the other side, cosine's undefined. Sorry, cosine's not undefined. Cosine's not undefined at either of these. Cosine is 0 at 3 pi over 2, meaning secant is undefined. Cosine is 0 at negative pi over 2, meaning, excuse me, secant is undefined. At negative pi, cosine is again negative 1, and at negative 3 pi over 2, cosine is 0, meaning secant is undefined. Okay. The other thing to remember is secants and cosecants are these U curves. So I'm going to have little U curves up here and down here, and then that pattern is going to repeat. Okay. So this is our basic secant shape. And now we need to think about, what have we done to that basic secant shape to get this? Well, there are several things that are different, right? We've got this minus 1 outside of everything. And that's the same thing as if I subtracted 1 at the end. And so that means this is a vertical shift. Down 1. Okay. If we've got vertical shifts, we might also have horizontal shifts. So how about a horizontal shift there? Our horizontal shift is going to come over here. So this is going to represent a horizontal shift. It's going to be to the left, pi over 2. This negative out in front, a negative out in front, is an x-axis reflection. And last, we've got a horizontal multiplier here. That horizontal multiplier is going to change our period. It's a horizontal stretch or compression. All right, so let's see if we can use all that information to sketch a graph of this transformed function. Okay. I'm going to draw a new graph. I'm going to put in kind of the same points that we had before. Pi over 2, pi, 3 pi over 2, negative pi over 2, negative pi, and negative 3 pi over 2. And we'll put in 1, and 2, and 3, negative 1, negative 2. Okay, all right. Now let's see if we can figure out what's going to happen here. In general, we're going to do our x-axis reflections first, or reflections in general first. So I'm actually going to sketch my x-axis reflection over here. When I reflect this, this piece flips down here. Well, it's going to look like this. And this piece flips up here. And this guy also flips up here. So those dotted purple lines represent our x-axis reflection. From there, we're going to think about shifting these things over and also changing our period. In other words, we're going to be squishing or expanding these. Let's think. We're going to squish or expand. This 2 means that I'm going to fit 2 complete u's inside my old period. That means I'm squishing my period down. Okay, my period is going to be half as big. If I want to find out exactly what my period is going to be, remember to find the period really of any of our trig functions. We take the original period. The original period of this guy goes from negative pi over 2 to 3 pi over 2. That's a half pi, another half pi, another half pi, another half pi, 4 halves of pi. Another way of saying that is 2 pi. So the period of this is 2 pi, and we divide by that horizontal multiplier. 2 pi divided by 2 is pi. Okay, so you're going to squish these down so that we get 1 period every pi units. Okay. The other thing that's going to be helpful for us to think about doing is think about taking this kind of basic starting plot here and moving it around. Okay. All right. So I can think about moving this guy around. When I move him, I'm going to have to horizontally and vertically switch him up, move him around. Sorry, I'm getting a little tired. So I'm going to move this point, excuse me, down 1 unit. Down 1 unit. It's going to get him down here at -2. And I also need to move him left pi over 2. So that new kind of point is going to be here at negative pi over 2, 2. So at negative pi over 2, 2. And I'm going to have to kind of squish this little guy down. Okay. Now the other thing that I know is I know that I get a period of this every, okay, sorry about that. Okay, so we've got sort of half of our answer here. Now the other thing that we need is we basically need to kind of finish graphing this guy by showing at least one little up guy. So the other thing that we know is we've taken our original period. Okay, here's our original period, 0 to 2 pi, sorry, 0 to 2 pi, but if we want to think about doing 1 up and 1 down, we can think of negative pi over 2 to 3 pi over 2. So here's our original period. We've shrunk it by half. So there's a shrink of a half. And we have also shifted it over pi over 2 to the left. Okay, so that means that this new period, right, is going to be pi units long, and is going to kind of go from here over to here. So we're kind of halfway in here, here. That's not right. That drawing. There we go. So our other one is going to be partway in there, looking something like this. Okay. So once we've got kind of 1 down and 1 up, that's pretty good in terms of thinking about sketching a graph. Okay. All right. So here's our secant function shifted horizontally and vertically, and also with our period compressed so that we get twice as many as we had before. Now, let's go ahead real quick and throw this up on Desmos and see how we did. So I'm going to share my screen with you. Maybe I can find the mouse. I can't. There it is. So I'm going to share my screen. And let's just real quick take a look at this guy right here, which is the guy that we graphed. So notice that we've got this point here at negative pi over 2, -2, just like we thought so. Our other up one starts at 0, 0, and we do have a period of pi. So there's 1 period, but we did kind of like to think about that being shifted over a little bit so that we could contain one of those full things. As opposed to drawing this period, we drew this period over here. All right, I'm going to pause, and then we'll do an example of a cosecant function. Okay, so let's try and sketch a graph of 2 plus cosecant of -1/2 x. So to start with, let's try and sketch a graph of the basic cosecant function. Okay, give myself a little more room here. All right, so I'm going to 1, -1, we'll put a negative pi over 2, that's not negative, that's positive. Positive pi and 3 pi over 2. Then we'll do negative pi over 2, negative pi, So negative 3 pi over 2. Okay, so when we're sketching this, the big thing to remember, right, is cosecant is 1 over sine. So anywhere that sine is equal to 1, cosecant is going to be equal to 1. Anywhere that sine is equal to negative 1, cosecant is going to be equal to negative 1. Anywhere that sine is equal to 0, cosecant is going to be undefined. Okay, so let's start with that last one. We know that sine of 0 is 0, which means cosecant is going to be undefined at 0. We know that at pi over 2, sine is equal to 1, which means that cosecant is equal to 1. We know that at pi, sine is equal to 0, which means cosecant is undefined. And we know that at 3 pi over 2, sine is equal to negative 1. All right, similarly, at negative pi over 2, sine is equal to negative 1. At negative pi, sine is undefined. And at negative 3 pi over 2, sine is equal to 1. So now we're just going to build our little U-curves. So here is a graph of our basic cosecant function. Now let's think about what we've done to that basic cosecant function to get our 2 plus cosecant of 1/2 function. All right, well, really only 2 major things going on. Here, this 2, this added 2 is going to be a vertical shift up 2. 3 major things going on. This negative inside with the x is going to be a y-axis reflection. And this 1/2 is our horizontal multiplier. And it's going to change our period. Okay? Okay. So let's see if we can start thinking about what these things are going to do to our cosecant function. All right. The first thing that we want to do is we want to think about that reflection, that y-axis reflection. Okay? So when we reflect this across the y-axis, this piece of our graph is going to flip over to here. This piece of our graph is going to flip over to here. Okay, this piece is going to flip all the way over to here. And this piece is going to flip way over here. So those dotted blue lines are going to be our y-axis reflection. Now, in addition to a y-axis reflection, we've also got this upshift of 2. That's pretty straightforward. That's going to take all of these and shift them up 2. Okay. And then the fun one, the one that's kind of fun, I guess, to think about, is we also have this 1/2 horizontal multiplier. So what that does is that changes the period. Now remember, we find the period of a trig function always in the same way. We take the original period. The original period of cosecant is 2 pi. And we divide by that horizontal multiplier. Notice I don't care about that negative. The negative just tells me about that y-axis reflection. I'm going to divide. I just said I don't care about the negative and then I wrote it. I'm going to divide by 1/2. But 2 pi divided by 1/2 is 2 pi times 2 over 1, or 4 pi. So our new period is going to be 4 pi. So that means when we're sketching this, our little U-curves are going to be much broader because they're going to encompass 4 pi instead of just 2 pi in a single period. All right, let's see if we can put all that together. Okay, so I'm going to put in sort of the same points. I have 1 and -1. And I know I'm going to have to be moving this up. I better go all the way up to 3 here. I'm going to do pi over 2, pi and 3 pi over 2, negative pi over 2, negative pi, excuse me, negative 3 pi over 2. Okay. All right. Now, this case is kind of nice because since we did not do any horizontal shifting, right, our periods actually didn't move left and right. In this case, our period only expanded. Okay. So our original period, if we come back here, looking at the red, our original cosecant graph, our original period went from negative pi to pi. Okay. we have expanded that, right? To go from negative 2 pi, which isn't even on my graph, I need to expand my graph, to 2 pi. How do I know? I know that because my period is 4 pi. So I've got to expand this to go from, sorry, I wasn't thinking ahead here. Here is negative 2 pi, and over here will be 2 pi. And that's going to be our new period. Our graph is going to have a period that goes from negative 2 pi to 2 pi, right? So that encompasses 4 total pi in the period. Okay, so remember then that we've got these two shapes that we have to fit inside of there. Now, one thing we can do is notice that our cosecants, right, between a period, right, we have one up and one down in this case. So these are split evenly between an up and a down. So if I take my period and I sort of split it in half, right, I'm going to get one up and one down inside of each of those. To decide which one I'm going to get, I'm going to remind myself about my reflection here. My reflection shows the down curve on the right and the up curve on the left. Okay? So I'm going to have my up curve over here and my down curve over here. The last thing I need to think about is kind of where do I start those things? Well, my original were here and here. Reflected went to here and here. So I need to shift these up 2. So this guy is going to go up 2 units and is going to start here at 1. So in the middle here, I'm going to draw, I don't know what my sound effects are about today, I'm sorry. My up curve, right, is going to go from 1, he's going to shift up 2, he's going to start all the way up here at 3. Okay, so there's my sketch of this graph here. Let's go ahead and go to Desmos and see how we did. Okay, so let me share my screen with you. Okay, hopefully you're seeing Desmos. And let's go ahead and look at our little graph here. All right, our period certainly goes from negative 2 pi to, 2 pi, just like we thought it would. Okay. And our up curve is here on the left and it starts at 3. Our down curve is here on the right and it starts at 1. Great job. All right, so that's a couple examples of graphing those. Again, the nice thing about these is they work really similar to what we've already graphed. We just have a sort of a new set of basic shapes to remember.